Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to IE 342 Quality Control. And today's lecture we will continue chapter 3 regarding to the probability distribution and a review for statistics. From the last lecture I have received a question regarding to the variance and standard deviation. And it's a valid question since usually that is covered in statistics based on the statistical background and mathematical formulation. And today I would like to show you in practical how is the use for the standard deviation. I will demonstrate the screen here and I will share it with you just to check on the voice. Is it clear? Okay, good. Thank you. Now let's share the screen. On the mini tab, can you see the screen? The mini tab screen? Good, okay. On the mini tab here, we have a data, and these data are measurements. You can imagine any type of measurements, like your heights here in the classroom. I can collect the 30 or 40 students here in the classroom, and we measure their heights, okay? Or you can measure the dimension of your product, or you can measure if you are a manufacturing or a factory for products, or you can measure the dates tamar from your farm. If you have a farm or you have a water company, you can measure the amount of water in every bottle. So these type of measurements, it was meant for heights and to show the difference between the variance and the standard deviation. Basically, I did that on the here in the mini tab as I showed you before. You go to display descriptive statistics under stat, under basic statistics, and then you choose the data from here on the column, and then you select the type of descriptive statistics you would like to show. And in my case, I choose only mean, standard deviation, and variance because I wanted to focus here on those only. And the results are here. So the mean is 394. I believe most of you know what is the mean because this is commonly used even if it is not related to the quality control or statistics. The idea of the variance and standard deviation, where is usually the confusion of students fall. Now, let's take it one by one. If we would like to talk about the one is practical to use in real life is the standard deviation. Why? Because looking to the standard deviation, comparing your height, if this is a height, you can tell how far you are in terms of the height from the mean. But if you would like to see how is each measurement was varying from the center point or the average point, this will show you how is the amount of the variation. And that's why the square used first to use it to show it as a positive value, because if you go to the mathematical formulation in the variation, you will see subtraction. And the square is to eliminate this if there is a case of a minus sign. And to show, for example, if we have the heights goes to minus, let's say the measurements goes to the minus. So you may have some minus values, and the variance would like to show you how each data in terms of the average, all of them, how each data is differ from the mean, And that is, if you read it, the 27,130, it shows you how the variation or the variance is big. But it doesn't really tell you for every single data. If we go to one of those measures, and imagine if this is your height is 170 here, or the height of the building, or I mean, you can compare it or refer it to another example where is the human height. If we imagine this is the 170 is your product height, and you would like to compare it with the average of the data, and how it is differ from the other data readings. When you compare the 170 to the variance, it doesn't really tell you anything. But when you compare it to the standard deviation, it gives you a reference how you are away from the other data, because the standard deviation shows that it is 164. The mean, it is only the add values or the sum values over the number of readings. But the standard deviation, it shows how it is differ from the mean, how it is differ from the mean. So the standard deviation in real life, it tells you more to compare your readings with the mean. And here in this consideration, it considered that the subtraction definitely between every reading and the mean after taking the square root from the variance. So the variance, it shows how the data is varying, how big is the variance or how small is the variance. But in real life, to show the scattered of the data or the distribution of the data, or how it is differ around the mean, the standard deviation, it is the practical number to be used. And that's why you see it in most of the quality control tools, like the control charts. When you draw the lines, we will see it inshallah in the coming chapters. When we draw the center line and then we start to draw the control limits, we will use the standard deviation, because it is going to show you the difference between, or the difference between the center line and the data, or the average of the data. And you can compare every single data to the standard deviation and show how it is away from the standards, because that is going or considered to be the standard, and the mean considered to be as an average or arithmetic average only, because as we said, it could be one data here like the 600, it increased the mean to 394, but it doesn't really tell me that how is the remaining compared to the mean. The mean, it can affected by only one reading. So the value of the standard deviation, it will show you for every data how it is differ from the standard. And the variance, it shows you how is the variation, how big the variation in the data. This is just to recap from the last session, and then we will go back to our slides. Continuing with type of distributions, we stopped where was the geometric, and we will continue from the normal distribution. Normal distribution is the most common distribution used. You can see its application widely in many applications, in different applications. Human height, human age. If you compare the age of the human being, 60, 70, around that is the people. There is definitely upper and lower tails of the distribution, but the average usually 70 and 60. If you compare the height, if you compare the average of success, normal distribution, mostly the common to be used in statistics, and it is very popular. The shape of the normal distribution is the bell shape. And as you can see here, the standard deviation appeared and multiplied with the factors that draw the deviation from the mean. That's why, as we say, the standard deviation is the most common used in terms of the inferences of the data. The central limit theorem, basically what it tells that any independent random variables can be approximately normalized using the central limit theory. If you have independent random variable, I believe you know what is the independent variable, the variable that is affect the results when you change it. So if you have a mean and standard deviation for those data, and it is independent, usually you can approximate it to be normal using the formula here. So it helps people because dealing with the normal distribution is easier in terms of the monitoring, in terms of the control, in terms of the improvement, and it is predicted. And as the name, it is normal, so you don't see extreme values like when we see in the exponential distribution. The followed distribution is the log normal. Log normal is also common in the failure mode systems or fatigue stress analysis that comes from the nature. Also analyzing stock prices. It is common in mechanical systems. All what you need to know is just the application of the distribution where it's used. As we say, those all of them can be calculated in the Minitab, and you as an engineer, it is okay. You have to be aware of those formulas and what they are represent, what factors represent the formulations like mean, standard deviation, but you don't have to go really in calculations because this can be automatically done. And all what we need as an engineer, and especially as an industrial engineer, to know how you use it or when you use it, where it is common to be seen. The exponential here is different than the normal. When we talked about the normal, it is dealing with the data that is commonly be seen. The exponential deals with the extreme values. When, for example, the rain event every month, sometimes it has a spike level in certain months in the year, so it is exponentially increased in the, for example, the winter or spring, especially for those countries who's having a lot of rain or snow. The exponential usually, as we said, analyzing extreme values, so it is opposite to the normal. The gamma distribution, it is also one of the distribution used for reliability. And the Weibel distribution, also used for reliability and survival analysis. So, and also for failures of components. You have seen many distributions, maybe, or a couple of distributions talked about reliability and failure. So you may be asked to have a list distributions that related to failure or reliability. So basically what you have to do is to name those distributions. So you know those distributions are commonly used in reliability or extreme values or or stock analysis or stock market analysis. So the use is what is needed from this chapters. Distribution identification example here. We are going to solve an example based on what we have learned and what is expected from you to understand at this level. As we said, all this has been intensively covered in the probability and statistics course. So here we are not going to dig inside the statistics, more of the application. And this is what is the engineers do, use science, mathematics to solve, which means apply them to solve real life problems. We have a similar to real life problem here. Let's read it together. A quality engineer for a nutritional supplement, مكملات غذائية company, wants to assess يقيم the calcium content in a vitamin capsule. So there is a vitamin capsule, capsulan vitamin, and it has calcium inside. And he would like to assess, يقيم الكالسيوم فيها. You are an industrial engineer, collects a random sample of capsules. يعني جمعت مجموعة من هذه الكبسولات. And records their calcium content. Recorded, سجلت نسبة أو كمية الكالسيوم. To determine which statistical analysis is appropriate for the data, the engineer first needs to determine the data distribution. The engineer performs individual distribution identification to determine which distribution best fits the data. This is a typical case you may see in it. You have a sample of data. You don't know what type of distribution you use, what analysis you should make. So based on what we have learned, you can predict maybe some of those distributions based on the nature of the data, but also the Minitab or all other statistical application software can give you the test for the data and give you the distribution, identify the best fit for the data. So from there, you can do your analysis, you can do your improvement, you can do your control. Okay, so let's take this example. The data is provided here in the Minitab, and I will share the screen again with you to demonstrate how are we going to identify the distribution for the given data of the calcium in this sample of capsules. So let's take share screen. This is the data as it is provided, and it represents the calcium amount in the capsules based on the sample taken, which was 50 capsules. طيب, what you do in the Minitab, you go to Stat, then you go to Quality Controls, and then you go to Individual Distribution Identification. Here, where you can see the description of that function is identify the appropriate distribution or transformation. It is written here in the title. Before you perform a capability analysis, when you use the ensure whether your data follow a normal distribution or no. So this is exactly what we said. Before you do the capability analysis, which will analyze the data or analyze the process, and then you would like to monitor it, maybe you want to use control charts, or you would like to do improvement. So you have to know what is the type of distribution, to know what you are dealing with, and what are the parameters you are expect to deal with. And when you press to this option here, you select the data from the single column, and it was here for the calcium. And then you leave it for the default option, because the default option use all distribution and transformation, and this is what we would like to do. You have more options here if you would like to choose the confidence interval. It is common to use 95, and then you press the OK. The data will, or the results will be demonstrated as you see here. You go at the end of the report here, and it shows you the goodness of fit test, and that tells you the ranking of the distribution fit, and it tells you that the normal distribution is the mostly fit here for this given data, and this is good. That means your data is following a normal distribution. Then you have a wide range of implementation, and the data is ready to apply all statistical analysis on it. Then the second one is box transformation. We haven't covered this one. If you would like, we can cover, but it is not really commonly used. The log normal, especially in the industrial level or manufacturing level, you will see log normal. Weibull, you see it. What else? The log normal, I would say, and the Weibull are the mostly common used, especially for failures, mood, and so on. Gamma, it could be, but it is really rare. Exponential, as we said, it is something that for specific applications to be seen. And in this case, we have the normal distribution, and the p-value, as much it gets low as mean that is a best fit. Also, it shows you the fit for every distribution here, and this is the good thing. It is visualizing also the fitness for use, or the data fitness here. For example, here the normal distribution, how the fitness is here, and also it shows you the log normal and the 3-parameter log normal, the the gamma. That's what we covered here. Also, it has to be having the exponential. I think this side, yes, it has the Weibull, the exponential, all of them, to see how it fits. You see how this is not really fitting at all, the distribution. And when it is aligned to the lines, especially now we are talking here, the middle line, that means this is a best fit, so within the boundaries of the distribution. That is what we use for as an industrial engineer, or what we apply. We use the distributions fit to understand the nature of the data, and it tells us what is the best distribution to be used for the data, so we can do our analysis. If you are not sure about it, definitely as much sample it is big as it is better usually to have a prediction about the distribution. So that was, we can say this is the type of application of this chapter, along with the use for every distribution that is expected from you to understand. You should also know the other applications. We have done it on the mini tab, like using or doing the descriptive statistics, drawing histogram, like what we did before, box plot, and do the inferences about them, what is the quartiles, and so on. Do the what else we covered here in the last lecture, the probability plot or the run chart that we have done it before. That's considered to be for chapter 3. It is easy chapter. Yeah, for the last chapter here, it shows you that the parameters, how it is considered to be good on, or when it's considered to be good. For example, like for the normal distribution here, the smaller p, it is better. And as we said, the larger n, that means the sample size, if it is large, it is better. But already these are done in the mini tab, and it is going to rank them based on this analysis. This is for your own reading. It is good to understand them and to be aware of them in terms of like profession, sometimes examination, where it needs you to do some interpretation for the parameters like the p-value or the n value, whether it is better to be big or small. That's all for the chapter 3. I would like from you to share your questions, your comments here, and we will continue or we will start the new chapter that's based on our syllabus on the next Sunday, inshallah. Now the time for any questions while I'm going to do the attendance. I hope that was informative enough for this chapter, and please share with me your comments and your questions.